Thank you. So this part is the intersection. So the total area of M is this part plus this part, which is 0.4. So now the question is it possible that the area of only this part is 0.5? This is not true, right? Because this area plus this area is equal 0.4. So this area cannot be more than 0.4. Even the intersection can be maximum 0.4 here. Why? For example, if this is our V and M is inside V. So if M is inside V and the area of this area is the area of M is 0.4. So if M is inside V, then the intersection of V and M will be M itself, right? Because V also contains M, right? So that's mean the area, maximum area of the intersection of V and M will be 0.4. So the area of the, or the probability of the intersection cannot be more than 0.4. So that's why this is not true. So now second question is, suppose that the intersection is given, probability of V intersection M is 0.3. Now we have to find what is the probability that the selected student has at least one of the two types of credit cards. So at least one of the two types. So that's mean the student has either Visa card or MasterCard or both. So that's mean we have to find the probability of V union M. So we already know that the union means the outcome is either in A or V or in both. So now we have to find the probability that the student has at least one of the credit card. So that's mean the student has either Visa card or MasterCard or both of the credit cards. So that's mean we have to find the probability of V union M. So how can I find this probability? So you can find this probability either using Venn diagram or you can also use the formula. So you already know the formula to find the probability of union. So you know that probability of V union M is equal probability of V plus probability of M minus the probability of the intersection part. So that's mean probability of B plus probability of M minus probability of B intersection M. So now we have all the information. So we are given probability of V, which is 0.6, 0.6, and probability of M is 0.4, and probability of V intersection M is 0.3. So now if you simplify this one, then it will be 0.7. So that's mean the probability of V union M is 0.7. So that's mean the student has at least one of the two credit cards is 0.7. Do you have any question? Okay, so part C is what is the probability that the selected student has neither type of card? So that's mean the selected student doesn't have Visa card or MasterCard. So that's mean the previous one was the student has at least one of the credit card. So that's mean part C is the complement of part B, right? Because the complement of at least one card, that's mean if you take the complement of this, that's mean opposite of this, then it will be no credit card. So that's mean the student doesn't have neither type of card. So this probability will be actually the probability of the complement of the union, right? So that's mean the probability will be probability of V union M complement. So this is actually 1 minus probability of, so you already know that the probability of the complement is 1 minus the probability of that event. So that's mean probability of 1 minus V union M. And from part B, we know that probability of B union M is 0.7. So that's mean it will be 0.3. So part D is described in terms of V and M, the event that the selected student has a Visa Visa but not a MasterCard. So that's mean first you need to write the event that the student has Visa card but doesn't have MasterCard. So a student have Visa card means V, but the student doesn't have MasterCard. So that's mean the complement of MasterCard. So that's mean V intersection M prime. So this is the event. So this is for per D. Okay, so the student has Visa card but doesn't have MasterCard. So this is the event for that. Now we have to find the probability of this. So how can I find the probability? Okay, so before doing this, if we want to find the probability that the student doesn't have MasterCard. So what is the probability? So a student doesn't have MasterCard means probability of M complement, right? So that's mean 1 minus probability of M. So this means the probability of that the student doesn't have MasterCard. Similarly, if you write V complement, so that's mean the student doesn't have Visa card. So now in part D, we have to find the probability that the student has Visa card but doesn't have MasterCard. So that's mean probability of V intersection M complement. So to find this probability, there are two ways to find the probability. One way is you can use the Venn diagram or you can use the formula. So the formula is probability of V intersection M complement. So which means probability of that event which doesn't have complement. So that's mean V doesn't have complement here. So probability of V minus intersection of the two event. So that's mean V intersection M. So why do we have this formula for probability of V intersection M prime? I can show you. So if you consider the Venn diagram. Okay, so this is event V, this is M, and the rectangle is the sample space. So probability of V means the area of this part. So this area is V. This area is V. And M is, this region is M. So now M complement, so we will shade the region for M complement. So what is M complement? So we can use different color. So we can use this color. So M complement means outside M. So that's mean outside M. So the shade the region outside M. So this is outside M. This is outside M. Because M is the blue part. So outside M will be this one. This is outside M. So now we have to find the area where we have V and intersection of V and M complement. So the black region is our black area is M complement and V is the red area. So what is the intersection of these two parts? So the intersection is this one, right? Oh, okay, let me draw it again. So yeah, the intersection of the red and black is the unshaded region, right? This one is the intersection of V and M complement, right? So now think about this. Or maybe I can open a new blank page. I think that would be better. Okay. So this is our Venn diagram. So the red one is, for example, the red one is V, and the blue one is M. So this is our M. This is our M. And this is, sorry. So this is our V. The red one is V. So the M complement will be outside M. So now shade the M complement. So M complement means outside M. So this is outside M. This is outside M. So this is outside M. Also this part is, this is also outside M. So this is also outside M, right? So M complement is, so V is, red is V, M is here blue, and M complement is black color. And the intersection of, so now V intersection M complement. So that's mean the common region or common outcomes between V and M complement. So that's mean the common part of red and the black area, right? So which one is the common part? So the common part is, now we can shade the common part, which is actually this one, right? This is the common part of red and black, right? So this is the common part. So that's mean V intersection M is this region, right? This is V intersection M complement. So now why the probability of V intersection M complement is equal? So this is still inside V, right? So that's mean probability of V. But we didn't include this area where we do not have black region, right? We have, so we did not include actually this region. So we do not include this region of V, right? So what is the event of this region? This is actually V intersection M, right? So that's mean minus V intersection M. So that's why the probability of V intersection M complement is probability of V minus probability of V intersection M complement. Is it clear, or do you have any question? Any question? Okay. So now we know that probability of V is 0.6 and V intersection M from part B, sorry, from, no, it was given in part B, which was 0.3. So that's mean the probability will be 0.6 minus 0.3. So which is 0.3. So the next question is, calculate the probability that the selected student has exactly one of the two types of curves. Exactly one of the two types of curve. So how can we calculate this probability? So exactly one curve means the student has either only Visa card or only MasterCard. So exactly one card means the student has either only Visa card or only MasterCard. So now you can see in the previous example, we calculated probability of V intersection M complement. So what does it mean actually? This means the student has only Visa card, not MasterCard, right? Because this is the intersection of the student has Visa card but doesn't have MasterCard. So that's mean the probability that the student has only Visa card, right? Similarly, only MasterCard means probability of only M means the student doesn't have visa card, right? But the student has, sorry, there shouldn't be complement, but the student has MasterCard. So only V means, so this is actually equal probability of only V. So the student has only Visa card means probability of V intersection M complement. So that's mean the student has Visa card but doesn't have MasterCard. Similarly, only MasterCard means the student has MasterCard but doesn't have Visa card. So that's mean the probability of V complement intersection M. So we already know the probability of this one. Probability of only V is 0.3 from the previous part, from part D, which is 0.3. Now you need to only calculate probability of V complement M. So how can I calculate this one? This is actually probability of M, because M doesn't have complement, minus probability of V intersection M. So which is actually the probability of M is 0.4 minus the intersection is 0.3. So this one will be actually 0.1. So this is 0.1. So now we have the probability that the student has only Visa card is 0.3, only MasterCard is 0.1. So what is the probability that the student has exactly one card? So that's mean either Visa card or only MasterCard. So you need to add these two probability. So that's what we did here. The probability of exactly one card means only Visa card, which is 0.3, and only MasterCard, which is 0.1. So you have to add them together, which is 0.3. Or you can also use formula. So the formula is exactly one card means the student has Visa card but doesn't have MasterCard, plus the student has MasterCard but doesn't have Visa card. Or you can also use Venn diagram. So how can we use the Venn diagram here? So I can show you. Okay, so we know that the probability of V is 0.6. It was given. Probability of M was 0.4. And probability of V intersection M was 0.3. So this probability were given. So now we can construct the Venn diagram. M is MasterCard, red is MasterCard, and blue is Visa card. So now this is the intersection. So this area is intersection. So what is the probability of the intersection? What is the probability of the intersection? V intersection M?
0.3.
0.3, right? So this area is 0.3. So now probability of V is 0.6. So what should be the area of this part? So what should be the area of this part? This area. The total area for V is, or total probability for V is 0.6, right? So this is 0.3. So what is the area of the outside of this part? It will be also 0.3, right? So this will be also 0.3, right? Okay, so this area is 0.3. So what will be the area of this part, this region? What will be the area of this region? So this is actually V, this is M. So what will be the intersection of V and M is 0.3, 0.3. The total area for M is 0.4. So what is the area for this part? If we deduct, or if we subtract the intersection part from M, then it will be 0.1, right? Yeah. So it will be 0.1. So this area is 0.1. So this is actually 0.1. So this area is 0.1. So now we have probability of V. So what we are looking for here, we are looking for the probability of V and M complement, right? Sorry, so we are looking for the probability of only V and only M. So what is the probability for only V? Only V is 0.3, right? So probability of only M is 0.1, right? The only M means the area of this region, which is point M, because that's mean the area of M or probability of M which doesn't include in V, right? Only M means the probability of M which doesn't include V. So if you subtract the area of V from M, then it will be only M, which is 0.1. And similarly, only V, the probability of only V is 0.3. Now we have to find the probability of exactly one curd. Exactly one curd means either only Visa card, exactly one means only either only Visa card or only MasterCard. So that's mean 0.3 plus 0.1. So which will be 0.4. So is it clear or do you have any question? Okay, so if you do not have any question, then we'll go over the next example, which is the route used by a certain motorist in commuting to work contains two intersections. So there are two intersections with traffic signals. The probability that he must stop at the first signal is 0.4. So the motorist will stop at the first signal and the probability is 0.4. And he will stop, or the motorist will stop at the second signal, the probability is 0.5. So the probability that he must stop at least one of the two signals. So at least one of the two. So that's mean the person will either stop at the first signal or at the second signal, or the person might stop at both signals. So this probability is 0.7. So we are given, if we consider if the person stopped at signal 1 at the first signal, then the event is 1. So if we consider 1 means the person will stop at the first signal, the person will stop at first signal, and 2 means he will stop at the second signal. So we have two events here. One means the event 1 means the person will stop at the first signal, and event 2 means he will stop at the second signal. Or you can also use different notation. You do not have to use 1 or 2. You can just use, for the first signal you can use F, and for the second signal you can use S. So it's always better to use letters instead of number, because number might confuse you. So you might get confused with the number. So it's better to use letters to represent the event. So for the first signal you can use F, and for the second one you can use S. Okay, so since in the solution we have used 1 and 2, so we'll go with 1 and 2. So we are given that probability of 1 is, so that's mean the person will stop at the first signal is 0.4, and probability of 2, so that's mean the person will stop at the second signal, is 0.5. And we have one more probability given, which is the person will stop at least one of the two signals. So that's mean the probability of the union of these two events. So that's mean probability of 1 union 2, which is 0.7. So now we have to find the probability that the person will stop at both signals. So that's mean that he will stop at the signal 1 and also stop at the signal 2. So that's mean we have to find the probability of 1 intersection 2, or 1 and 2. So now we do not have any direct formula for this one to find the probability of 1 intersection 2, but we know the formula for probability of 1 union 2, right? So we know the formula for 1 union 2. So this is equal probability of 1 plus probability of 2 minus probability of 1 intersection 2. So we know this formula. And we are also given some information. So we know the value of this one. We know the value of this one. So we know the value of this one, right? So now you need to find the value of this one. So if you just plug in all the numbers and if you solve for probability of 1 intersection 2, you will get the results. So 1 union 2 is 0.7. One is probability of 1 is 0.4 and probability of 2 is 0.5. And we have to find this one. So you have to just solve this equation for probability of 1 intersection 2. And finally, you will have 0.2. So this is the probability that the person will, or the motorist will stop at both signals. So part B is at the first signal. That means the motorist will stop at the first signal, but not at the second signal. So that means actually we are looking for the probability that the person will stop okay. So the next part is we have to find the probability that the person will stop at the first signal, but not at the second signal. So how can we find this probability? So actually we are looking for the probability where the person will stop at the first signal. That's been probability of 1, and he will not stop at the second. So that's mean 2 complement. So the person will stop at the first signal. That's mean probability of 1, and so intersection, the person will not stop at the second signal. So that's mean 2 complement. So now we have to find this probability, and we know the formula. So 1 intersection 2 complement is probability of 1 doesn't have complement. So it will be probability of 1 minus the intersection of these two events. So 1 intersection 2. So this is equal 0.4 minus 0.2. So it will be 0.2. Okay, so you can also use the Venn diagram. So the Venn diagram means, so you can use this one. So the person will stop at the first signal. The probability is 0.4, and the probability of the intersection is 0.2. So the probability of the yellow part will be 0.4 minus 0.2, so which is 0.2. And for this one, the total for second signal, the probability total probability for the second signal is 0.5. So this is 0.2. So probability of this part will be 0.3. 0.5 minus 0.2, which will be 0.3. So how did we calculate the probability, this outside probability? We know that total probability is 1. So probability of the region 1 and 2 So this area is 0.2 plus 0.2 plus 0.3. So 0.7. So probability of outside these two region will be then 0.3 because the total probability is 1. Okay, so for part B, you do not actually need, you do not need all this information. You just need this probability of 1 and probability of 1 intersection 2. So that's it. Okay, so next part is, okay, so I think there is another question. Part C, the person will stop at exactly one signal. So exactly one means the person will either stop at the first signal or at the second signal. So that's mean we have to find the probability. Exactly one means exactly one signal means only at one plus probability of only at 2, right? So that's mean we have to find the probability of 1 intersection 2 prime or 2 complement plus 1 complement intersection 2. So we already know the probability of this part, which is 0.2, and probability of this part will be 2 doesn't have complement, so that's mean probability of 2 minus the probability of the intersection. So that's mean probability of 2 is 0.5 minus the probability of the intersection part is 0.2. So probability of 0.5 minus 0.2, which is 0.3. So probability of this part is actually 0.5 minus 0.2, so which is 0.3. So then the total probability will be 0.2 plus 0.3, which is 0.5. Do you have any question? Okay, so we'll go over one more example here. So a certain system can experience 3 different types of defects. Let 1 is equal defect type 1. So there are 3 types of defect: defect 1, defect 2, and defect 3. So a system can have these 3 types of defect. And we are given the probability that the system has defect 1 is 0.12, defect 2 0.07, and defect 3 0.05. And we are also given that the probability of 1 union 2, so that's mean the system has either defect 1 or defect 2. So which is 0.13, and probability of 1 union 3, that's mean the system has either defect 1 or 3. And probability of 2 union 3 means the system has either defect 2 or 3. And probability of 1 intersection 2 intersection 3 means the system has all 3 defects. So this part means the system has all three defects. Okay, so now the question is, first one is, what is the probability that the system doesn't have a type 1 defect? So that's mean this is the complement of type 1 defect. So that's mean we are looking for the complement of type 1. So 1 is type 1. So that's mean we are looking for the probability of 1 complement. So which is 1 minus probability of 1. So that's mean 1 minus 0.12. So this is 0.88. Okay, second question is, what is the probability that the system has both type 1 and type 2? So that's mean in part B, we are looking for probability of 1 intersection 2. So what is the probability of 1 intersection 2? So we do not have direct formula for this, but we know the probability of 1 union 2. So we can use this formula to find the probability of 1 intersection 2. So 1 union 2 is equal probability of 1 plus probability of 2 minus probability of the intersection of these two events. And we are given that this is 0.13 and this probability of 1 is 0.12, probability of 2 is 0.07, and we have to find this probability. So if you solve this equation for probability of 1 intersection 2, then finally you will have 0.06. So the probability that the system has both defect type 2 and type 1, so which is 0.06. Okay, so next question is, what is the probability that the system has both type 1 and type 2 defects, but not type 3? So that's mean we are looking for the probability that it has one, defect type 2, but do not have type 3 defect. So that's mean we are looking for the probability of 1 intersection 2 intersection 3 complement. So we have to find this probability. So to find this probability, you can use either Venn diagram or you can use formula. So what is the formula for this one? So we know that formula for this one is, for example, A intersection B complement is equal probability of A minus probability of A intersection B. So that's mean the first one is the probability of that event which doesn't have complement, right? So that's mean probability of A. And this part is the intersection of the two events, the event A and event B. Similarly, if we want to use the formula for this one, here we have three events. But if you consider these three events as two events, for example, if you consider this event together, then how can we write the above formula? So then it will be probability of which event doesn't have complement? The first one, right? 1 intersection 2, right? So that's mean 1 intersection 2 minus probability of, can anyone tell me? 1 intersection 2 intersection 3 or 3 complement? Anyone? So it is 3 or 3 complement. Okay, so if you consider 1 intersection 2 as A, so this is considered this one as one event. So that's mean we are looking for the probability of this event intersection the complement of another event. So the formula for this one is probability of this event which doesn't have complement. So that's mean probability of 1 intersection 2 minus the probability of the intersection of this one and intersection of this one without complement. So that's mean you have to write this one first and then intersection and this one without complement. You already know the probability of 1 intersection 2, right? From part B, I think you already, from part A maybe, yeah. So you already know the probability of 1 intersection 2. Yeah, from here, we already know this is 0.06. And we also know the probability of 1 intersection 2 intersection 3, which is 0.01 here. So we know these two pieces of information and we only need this information to find the probability of 1 intersection 2 intersection. So the probability will be then 0.06 minus 0.01. So which will be 0.05. So you can use this formula or you can also use Venn diagram, but constructing the Venn diagram for this one is little tricky. So it's better to use the formula. So part D is, what is the probability that the system has at most 2 of this effect? So that's mean probability at most 2. So that's mean maximum 2 effects. So what is the maximum effects the system can have? Sorry, maximum defects the system can have. So how many defects we have total here? We have total 3 defects, right? 1, 2, 3. So we have total here 3 types of defects. So that's mean the system can have maximum 3 defects. But we want to find the probability that the system has at most 2 defects. So what does it mean by at most 2 defects? That's mean the system can have 0 defects. That's mean there is no defect, can have 1 defect, can have 2 defect. But the system cannot have 3 defects, right? So we are looking for the probability at most 2. So that's mean the probability that the system doesn't have all 3 defects. So at most 2 is the complement of all 3 defects, right? Is it clear? Since there are total 3 defects, so the system can have 0 defects. That means the system doesn't have any defect. The system has just 1 defect. The system has 2 defect. But the system cannot have 3, because we want to find the probability at most 2. So that's mean the system cannot have 3 defects. So that's mean we are looking for the probability of complement of all 3 defects. So that's mean this is equivalent to all 3 defects, complement of this one, right? So then we can write 1 minus probability of all 3 defects. And all 3 defects means the intersection of 1, 2, and 3, and which is 0.01. So 1 minus 0.01 is 0.99. So this is the probability. Okay, I think we do not have time, so I'll stop here. And this is this is quiz time. So for quiz, you have to log into WebAssign, and you will find 2 questions there. And this is your first quiz. So on WebAssign, you will see quiz 1, and there are 2 questions. So you will have total 30 minutes to answer all 3 questions. Sorry, all 2 questions. Okay. Do you have any question about quiz? The quiz is due by 3:20 p.m. Yeah, today. Yeah, now. Yeah, you have to take it now. So you will have 30 minutes to finish the quiz. So it will start at 2:50, and you have to finish it by 3:20 p.m.